Hey guys, Daryl here from Victory 4x4, and I'm here to talk to you about gear installs. Now this is not meant to be a full overview on how to do gear installs, but just a little primer on the things that people are the most worried about. And those are the little minute settings that you're actually doing when you're doing a gear install. I assume that if you're willing to even watch this video or start this project, you know how to take the axle shafts out, and you know how to remove the diff cover or remove the third member in this case, and you have a pretty good mechanical knowledge, but maybe you've never set gears before and you're not sure exactly what you are looking for. There are a few settings when you're doing a gear install that you're looking for. First of all, you're looking for the depth of this pinion right here in the housing. So by changing shims, you are moving this pinion in and out of the housing, or closer or farther away from this ring gear. And we're not moving it very much at all. So we're moving maybe 10 thousandths or 5 thousandths at a time to try to get that ring gear. And a 10 thousandths change can be a pretty big change. So one of the first tools you're going to need is a really good set of micrometers. You just need them to be accurate. So even if, I guess you don't need a great set, even if you get a cheap set, you want it to be repeatable. So even if they're wrong, as long as they're wrong repeatably, you shouldn't have any problem. But what this is going to do is going to let you measure the thicknesses of your shims that come in your install kit, the shims that came out of the differential from the OEM. Then you can kind of work from there. So pinion depth is one of the big settings that you're going to change, and I'll show you how that affects the pattern on the ring gear. The other thing you need to worry about is pinion bearing preload, and that's how much force it takes to turn this pinion. So there's two bearings here. There is an inner bearing and an outer bearing. So it's the relationship between these two bearings inside here that sets this bearing preload. So there's a couple things that, there's a couple ways that you can do that. You can use what's called a crush sleeve. This actually sets between the two bearings. It holds the bearings apart, and this portion right here is meant to collapse under pressure from this pinion nut. The problem with the crush sleeve is they're one-time use. Once you crush them once, you cannot do it again. You're supposed to replace them if you ever pull this apart, and torque could technically push down on the yoke or the flange and compress this more. Now in this Toyota, we're not worried about torque doing that, but in higher horsepower applications, that's definitely a problem. So in here, what we have is called a solid spacer, and it basically is just a piece of machine tubing with no spot for it to crush, and then you change its height with these shims. Then you change its height with these shims, and these are provided by Nitro Gears for the install kit. So you add these little shims here onto that solid spacer, and that pushes the bearings away from each other, and that sets the pinion bearing preload. It's pretty simple. And then bearing preload is measured with another tool. This right here is an inch-pound beam torque wrench, meaning that we're not setting it to a click-click torque. We're checking to see how much torque it takes to rotate. You see, if I hold it and I move this right here, it measures in inch-pounds the amount of torque that it's going to take to rotate this. So if we grab our socket here, we can rotate this diff and see that it takes maybe 8 to 10 inch-pounds to rotate this. And this is dry. There's no lubrication in this differential. And on used bearings, which there are in this gear set, I should see 5 to 6 inch-pounds. But since this is a brand new truck and these bearings are dry, I'm going to say that 10 inch-pounds is just fine. On a new gear set install for this Toyota 8-inch, let me see here, we're looking for 14 to 17 inch-pounds on new bearings, but then these are not new bearings. That is just perfectly fine. So that is pinion preload and all of that. So the next measurement we have to worry about is backlash. And what backlash is it's how much this ring gear can turn before the teeth engage with the pinion teeth. So you can kind of hear that clunk clunk there. And what that's for, it's for really oil clearance, and as these gears heat up, they'll actually take up, they'll expand, and they'll take up a little bit of that backlash. So you want these gears to actually run on a little bit of oil on the surface, and you also don't want them to heat up and smash together. So what you need to do is you need to move this carrier away or towards the pinion gear to change that backlash. on this dropout third member in this Toyota, we do that by turning these spanner nuts either one way or the other, and they're threaded, so they push on the carrier bearing caps and they will push that this way or that way. On your Dana axle, you're going to have some shims, and they're either going to go underneath the carrier bearings here, or they're going to go on top of the carrier bearing races. So you can move those shims from side to side, and you can actually change where this ring gear is in relation to the pinion. So on this Toyota, we're looking for 6 to 10 thousandths of an inch of backlash, and we're going to measure that with this dial indicator here on this magnetic base. Now, sometimes setting these things up can be more of a pain in the butt than actually just taking the measurement, so sometimes you have to fight a little bit with exactly where you want to set them up. But usually what I do is I try to get to a ring gear bolt. And you want to tighten them up so that it doesn't move at all. You don't want the dial indicator or the base to move. So really what we're looking for, oh, looks like we're bound up a little bit right there. There we go. So what we're looking for is we're looking for 6 to 9 inch-pound, or I'm not inch-pounds, I'm sorry, 6 to 9 thousandths of an inch on this gauge. So if we turn our 0, you can see right there, we are at 15 thousandths of an inch. So that is too much. So all we have to do on this differential, which is really nice for the dropout third member, is we have to loosen up these bolts first. And then since we have too much backlash, we just have to move the ring gear towards the pinion. So we do that by turning, and I'm just going to loosen one more here. So we need to move this ring gear towards the pinion, and we do that by turning these spanners on this dropout third member. So we go ahead and open this one up just a little bit, thread it away from the bearing cap, and that gives us some room to thread this side towards the bearing cap. And then we have to lock this back down. I'll do this one with a wrench, so then I won't have to move this again. Lock this down. Re-zero our dial indicator. Zero's back here. And then we check. 11. So we need between 6 and 9. So we need just a little more here. All right. Make sure our dial indicator isn't bound up still. Back to 0. Now we have 3. So you can see how this is sometimes a tedious game. So the spanner nuts make it a little easier than if you have to move a shim every time. And way easier if your shims go underneath the bearings, because then every time you have to change this backlash, you have to pull the bearing caps off from your carrier, and that can be tedious and annoying. So you can kind of see why people call gear installs tedious, because sometimes they can be. Okay. Back to 0. 8. Perfect. 8 thousandths of an inch. That's perfect. We're gonna want to measure this on multiple points on the ring gear to make sure that we are the same all the way around. But I've done that earlier when I set this up the first time, and these Nitro Gears are great as far as quality and machining goes. So 8, perfect. We are in spec on that. So once we get the backlash set, then we're going to talk about the things that scares people the most, and that is checking the pattern. All right, so this is the scariest part of gear installs for most people. That is reading the pattern. It's kind of an art form. I'm going to try to simplify it the most that I can for you. And this really only applies to new gears. If you're setting up a set of used gears, you know, that's black art. You're gonna chase that pattern for a while. But so this concave side is the coast side, and the convex side here is the drive side on a low pinion differential when we're talking about that. So the top of this tooth is the face, and the bottom of the tooth is the flank. The toe is right here, and the heel is right here. So what we're looking for on both sides, on the coast side and on the drive side of the gear set, we are looking for this pattern where the ring gear teeth wear off the marking compound to be centered from the face to the flank and from the toe to the heel, so centered. We're looking for this feathered edge. You can see that it's got this feathered edge right here on the top, like this, feathered, and on the bottom, right here, to be feathered. This is a proper pattern. This pattern is a perfect pattern. Well, not perfect, but it's very, very close. Centered in the tooth, centered top to bottom. We are more worried about it centered from the face to the flank, or the top to the bottom of the tooth, than we are from the heel. I always mix these up, from the heel to the toe. That matters, but it doesn't matter as much as from the face to the flank. And a lot of times what can happen is you can change this pattern from the heel to the toe. It's just a backlash setting. So if your backlash is dialed in, you can get this pattern centered in the tooth most times, or centered in relation to the drive side and the coast side. Sometimes you'll see that the coast side is here and the drive side is up here on the back side of the tooth. That means that your backlash is wrong. Typically, or you've got a bad set of gears or a used set of gears, and all that. So that's a good looking pattern. I've ran a few patterns on this, so let me see if I can find a bad one. Yep, right here. So this is my last pattern. So as you can see with this pattern is we're too deep. The pinion is too deep into the ring gear, so we have that nice feathered pattern up here, right? But it cuts off. There's a sharp cutoff on the bottom. So there's that very sharp cutoff. Let me get a little more light in here so that I can... Maybe this will help a little bit. So there's that sharp cutoff on the bottom. That means the pinion is too deep. And this was only 5 thousandths of an inch difference between this pattern right here and this pattern right here. So I took 5 thousandths of an inch of shims from between the inner pinion bearing and the pinion head to change from this bad pattern to this good pattern. That's why gear installs can be frustrating for people sometimes, because you're making very, very minute changes to get what you're looking for. And then I can show you another pattern if it's still on the tooth. I might have wore over it at this point. No, that pattern is pretty much gone. The other pattern I had was a too shallow pattern, and what that was 10 thousandths of an inch shallower. The pinion was 10 thousandths of an inch deeper into this third member than my too deep pattern, and 5 thousandths of an inch shallower than my correct pattern. And it looks like I wore that one over already. So as you can see, I don't have a lot of marking compound, but that same pattern matches on the drive side as well. And there's some talks about whether or not the drive side is more important than the coast side, but honestly, they're both important. So get this pattern right here looking the same on both the drive side and on the coast side. Now, the other thing that can make this frustrating is where your shims are designed to go from your master install kit. If they go between the pinion bearing and the pinion head, that means that you change the depth of the pinion by adding shims underneath the bearing. That means that the relationship of the inner and the outer pinion bearing doesn't change. So if you add or remove shims from between the pinion bearing and the pinion head, you're not changing anything in the relationship between those two bearings. That means that that pinion bearing preload that we talked about before, you only have to set it once. You don't have to worry about it. But if your shims are designed to go under the race, so the inner pinion bearing has a race that's in the differential or in the third member, and sometimes the shims are designed to go in there. That means you're spacing the race in or out in the carrier or third member, which moves the pinion in or out, yes, but that actually changes the relationship between the two pinion bearings. So what you'll have to do is, say you add 10 thousandths of shim underneath the race on the inner pinion bearing, you'll need to add 10 thousandths of shim to your solid spacer or get a new crush sleeve. So that's why I don't recommend installing your crush sleeve finally until you have a correct pattern. Just use the old crush sleeve, just kind of get a general pinion bearing preload while you're checking for your patterns. And the same thing goes for, like we talked about earlier, for these carrier bearings. If your shims go between the carrier bearings and the carrier, then it takes a little more work to get this correct backlash than it would if they just go on the outside of the carrier bearing races, or if they go on these spanner nuts. Now, carrier bearing preload isn't something that's talked about a lot, but it is important. If you have a case spreader, a device that actually goes in those little holes on the side of your differential and spreads it open so that you can slide your carrier in and out easier, maybe you can start thinking about how many shims you're going to add or remove to get that carrier bearing preload perfect. But the way I do it here, and the way I've done it for a long time, is I set my backlash, whatever that is, with the carrier just kind of difficult to install and remove, but not impossible to install and remove. And then maybe after that's all done, I'll add an equal amount of shims on each side. So maybe it's 3 thousandths or 5 thousandths or whatever that is on each side, just so I have to put that carrier in with a dead blow. So it actually takes some force to get that carrier into the differential with a dead blow, or maybe a brass punch if I have to. And then I know that I've got enough carrier bearing preload. If you're hitting it in with don't ever hit anything with a 5-pound sledge, but if you got to jam it out with a curl bar, you might have a little too much. But people don't really talk about carrier bearing preload much, so I've never really messed with it a ton. I've always kind of set it the same way. So you can look online for some more research on that, but that's the way I do it. If you're using spanners like this, I will get it the backlash right, and then I will tighten each side equally, just so I get, pretty snug, just so I kind of get it where I feel like it needs to be, and I set up. Never had an issue with that, no problems. Other little simple things: Loctite all these ring gear bolts. Always Loctite. Make sure they are torqued as well. Figure out torque specs, make sure they're torqued. Loctite these carrier bearing cap bolts. Make sure they are tight, Loctited clean before you install them. Make sure everything's clean underneath the bearing. And a little piece of dust between a bearing and a carrier, or a bearing and a pinion, or a shim, it's going to screw you up. It's going to affect your measurements forever. So make sure stuff is clean. And then this pattern, that's really the hardest part. I mean, honestly, everything else is just labor intensive. Pulling bearings. Oh, another thing on that. To pull a pinion bearing, you can use either a specialized tool. They make a cup that fits over the bearing and a puller and all that stuff. What I've always used is a clamshell like this. Underneath, between the pinion bearing and the pinion, clamp it down, and then I use just a standard shop press to press it out. Flip this over, with a piece of tubing on top of it, set the bearing, set the pinion. You can press the pinion head down into the bearing. That's the way I've always done it. They do make specialized tools, but at a bare minimum, the tools you're going to need to do this are a beam type inch-pound torque wrench. These are not expensive. A clamshell and a shop press. You don't need a huge shop press. Anything will do. Brass punches. You want to always press on, or you want to always tap out races, pinions, all that stuff. You want to do it with brass because it will not mar the metal surfaces of anything. But you want to be careful. The one thing about brass is little brass fragments can chip off while you're hammering a race in if you don't have a set of race hammer tools to do that. So you got to watch out for those little pieces getting between your race and your carrier surfaces. So make sure that you watch that. For this dropout third member, you're going to want a spanner wrench to turn those spanners. You're going to want a set of calipers and a dial indicator with a magnetic base. Besides that, just your general standard shop tools. Most of your install kits are going to come with a brush and with this gear marking compound. And just time. You know, you don't want, this is not something you want to do in an evening. Your first time, you want to give yourself enough time to figure this out. But really all it is assembling, checking a pattern, blowing apart, moving shims, assembling, checking a pattern, blowing apart, moving shims, endlessly sometimes. That's why these are so expensive. And then once you get that proper pattern, then you just want to make sure that everything is clean, Loctited, properly torqued, and you're good to go. Fill it up with gear oil, follow the proper break-in procedure for whatever your gear manufacturer recommends. Swap the gear oil out, and you will have a very long life of your gears. But the most important thing is that you follow the recommendations of your gear installer for whatever spec your model is. So backlash and all the preloads and all of that, and make sure that you have a proper pattern, because a gear set is only strong the way that it is designed to be set up, and it's designed to be set up with the teeth meshing in the center of each other, basically. So that's really all I have. Like I said, this isn't a full overview on how to do a gear install, but I just want to talk about the things you're going to worry about, the things you're going to think about if you're thinking about doing this. If you have any questions, put them in the comments below. But thanks for watching, and I'll talk to you later.